Hey guys, I just wanted to start this video off by saying that I've never really done something like this before, so if I could do anything better or if you guys have any constructive feedback, please let me know. This video is going to be more for the in-depth dive into the code, and I'm also going to have some kind of blog post written up about this. I don't have a blog set up yet, but I will make sure to do that before I upload this video, and I will post the link to the blog in the description as well as the link to the GitHub source code so that if you guys want to skip this video right now, you guys can just go straight there and grab the code if you guys want to use it. So let's dive into what we've got going on here. First off, let's just see what we're going to be seeing on the screen. So we've got our emulator here, and we just have a list of data being set up with RecyclerView. Each view has a little circular background, an icon, and a text view for the name. So I can scroll through this, and it scrolls like a normal horizontal recycler view would. Nothing too fancy. It's just centered in the screen, and you can scroll through it. So what we want to do with this video is, or with this app, we want to do something pretty cool here. So if we were to imagine the center view in the center of the screen here as a larger scaled view, and as you scroll, the views on the side of it are scaled to a lesser extent. I don't know if I really drew this the best way, but basically the view that's in the center of the screen will be larger, and as this view moves away from the center, it will slowly get down to a smaller size, very gradually, of course, and this will create like a nice scrolling animation. So that's going to be the purpose of this video. So let's dive into the code. I'm not going to go too in depth of what I've already got because it's just kind of a simple recycler view setup with some static data, and I know that's not really the purpose of this video, so I'll try and keep it to a high level as much as possible. So what do we have? We have a recycler. We have first of all, the main activity. We have a simple item adapter, which extends the typical recycler view adapter. We have an item view holder that inflates that is past a inflated view of list item. Now this item view holder does a couple things. Let's just dive into the list item itself real quick so you guys can see what's going on. Like I said, we have an item background that's just a circular drawable. Nothing fancy there. It's just a blue circle XML drawable file. We have a list item icon. This is all in a relative layout so that things can be stacked on top of each other. I could have also used a frame layout, but that's beside the point. So we have a list item background is a circular background. On top of that, we have the icon, and we also have below all of that the list item text. So that's how we get the look of each view holder that we have here. Now, of course, that's all wired up in the adapter. So we inflate that list item. We get the item at the position of the list, and we bind to that view holder and set up that stuff. So like this is all like pretty standard stuff. I don't want to spend too much time on this. The main activity is just a linear layout with a horizontal carousel recycler view. Now that sounds fancy, but all it is just a regular recycler view at this point. This is important to note that I only pulled this out at this point because I know we're going to be writing custom code here, and I want to keep as much code out of the activity as possible. So as much code that can go in this custom recycler view code as possible, the better. So that's why I abstracted this class now. So we can close out of this list item. We're not going to be looking at that anymore. The main activity, we're actually going to be coming back to this in a little bit, and I'll explain later. But there's only going to be one line changing here. And right, so the main activity just holds a standard recycler view at this point, even though it looks like it's different. The main activity holds a list of things. So I have a data class down here called item. And let me just close out of some of this stuff so you guys can have some more visual room. So we have a data class of item. If you guys aren't familiar with Kotlin, don't be scared. It's very similar to Java. There's just a few niceties that you get with it. So like a data class is just a regular object class that gives you a couple extra things with it, such as equals to and hash methods and stuff like that. So not important that it's a data class. It's just they're really easy to work with. So I've got a data class of item, and each item will have a title and an icon. I construct a list of possible items and just say that these are the 5 possible items that I can have. I've imported some icons over here from the Android standard set. Airplane, car, food, gas, and home. Nothing too fancy or important there, just kind of arbitrary icon choices. And so yeah, each item has a name and an icon with it. And when we create the activity, we're just going to get a large list of items. So I just thought it would be helpful to have more than 5 things on a list, but I also didn't want to spend the time to set up 15 or 20 different items. So what this is doing, it's not very important. Just know that it gives you back 40 items for the recycler view. But this is a for each from 0 to 40, and for each one of those integers, 0 to 40, we add a new random value from the possible items to this items list here. And then we return the items list. So it's basically just 40 random things out of these possibilities. So yeah, when we create the activity, we first set up the linear layout manager, which is a horizontal layout manager. You can do vertical, or you can do whatever you want here, but I chose horizontal because that's kind of the feel I wanted to go for. Now, we also set up the adapter. The item adapter is constructed by Lazy. And like I said, if you're not familiar with Kotlin, Java also has variations of the Lazy constructor. But basically, what this is saying is that this item adapter is not constructed until it's asked for. And when it's asked for, this is how it's constructed. So when I ask for an item adapter, it's just going to construct an item adapter. Not very important, but that's just kind of the convention that I'm used to, so I did it that way. So we set up the layout manager, we set up the adapter, and then we set the items on the adapter. And we've already gone through the adapter stuff, like I said, not very important. So pretty much everything you've seen here is very standard, and that gives you this nice horizontal recycler view with some items in it. It just behaves like a normal recycler view, but we're going to change that. So before you get into the custom code, custom view code is very complex, or at least it can be, but it also doesn't have to be. It's really helpful to take a step back and really just think about what you want to do, what your goal is, and how to achieve that. So if we think about this, if we bring back our example, our terribly drawn example, that is not even a circle, but it's meant to be. It should be a circle. Right. So like we have this set of views, and we want the scale. So like if I could draw like a magnitude. If you can recall your physics classes, I got a vector here. And this vector represents the scale of this view. So at the edges of the screen, this vector isn't very large. As it gets towards the center of the screen, it gets a little bit larger. And at the very center of the screen, it's absolute largest. And as you move to the right again, that vector, that magnitude, that scale, it decreases. So like you just got to think about from a different perspective, not even a coding perspective, but like how would you make this happen from a mathematics perspective? Because we're going to be using some kind of mathematical function to drive our scale. So how we do that is, I don't know, maybe you should trace the magnitudes, right? So even just from a non-nice way, I guess. This is just it looks kind of weird, right? If you were to graph this function, on a graph, right? This is what you would get, some kind of axis, right? Well, what does this represent? It kind of just looks like 2 lines, but you could also think of it more of like a bell curve. So if I could change my color here, I might be able to see a little bit better. So it kind of resembles a bell curve. And bell curves can have different magnitudes and different spreads and different standard deviations, etc. But the point is, this pretty much resembles a bell curve. And that's going to be the function that we use to drive the scale of this. So, let's figure that function out now. We don't have to get too precise with the numbers at this point, but let's just figure out the general formula that we're going to use. So, if you can instantly recall a Gaussian function formula in your head, that's great. But of course, I looked it up because I can't do that. So the formula for a Gaussian function is alpha multiplied by the constant e to the negative power of x minus b squared. It's kind of hard to draw with this mouse, but divided by 2c squared. Now, this might look complicated, but if you just break it down into a linear format, like it would just be, a times by e times by, the power of. But, we'll be writing it out in code later, so it will be a flat function. But what these numbers boil down to is a is equal to the magnitude of the bell curve. So how tall do we want this bell curve to be? How large do we want this scale of the view to be in the center of the screen? That's what A is going to be for. E is a constant, so that means nothing to us. Maybe this will work better if I just drew some arrows. So A is the magnitude, and X is going to be so if you remember in mathematics, like, the function of x, right? Like, this is what we're solving for. So, like, how do we get this number? Well, if you think about a bell curve on the x-axis, and you want the or in a xy axis, you would want the value at this point, right? Like, just off the center of the screen. Well, that's your x value here. So if this is where the child is at on the screen in relation to the x-axis, then this x is just the center of the child. And by center, I mean the x center of the child view, or the view holder. So it's not actually as complicated as it has to be. Now B just relates to the center of the bell curve. And in our case, that's going to be the center of the screen. Or if we want this thing to be a little bit more dynamic, maybe the recycler view wasn't taking up the whole screen, then B is just going to be the center, the x center of RecyclerView. I apologize for my terrible handwriting with the mouse. So X is the center of the child. B is the center of the recycler view, and C is going to be the standard deviation, also known as how wide do we want this bell curve to be. So we could have this thing be super wide, kind of like this, or we can have it be super skinny like this, and this is all dependent on how gradually do we want to scale these views horizontally across the screen. If a view is here and here on this curve, they're going to have the same scale. Whereas on this curve, these are going to be scaled more and more as you get to the center of the screen. So it just kind of depends on what we want to do scale-wise across the center of the screen. So we have a little bit of work to do in the code now. So if we come back to the code, it's kind of hard to always figure out what you want to do first. I have a little bit of insight on how recycling views work and abstracting code and stuff like that. So I already know that I'm going to need to be setting up an adapter data observer on the recycler view, or sorry, on the adapter that's set up with the recycler view. I'm going to need to do that because when things are added to the recycler view, we're going to need to recalculate the scales of these things. So I'm just going to set up a method with the recycler view. There's setup adapters already taken by the recycler view, so I'm just going to do maybe initialize. Doesn't really matter what you call it at this point. Okay, so we're going to have this initialize function, and we're going to want to pass in an adapter to initialize this thing with. Okay, adapters are typed, so I have to type this thing. Like this would, technically I could just say, like, I have the item adapter and the item view holder, and I know this is what it's going to be passed in, but let's just make this thing a little bit more dynamic. Let's make this thing not so hard-coded. So I could type this function and say, this function is going to take in the type of T, which is a type of view holder. If you guys have never worked with type functions before, this is a good introduction for it, because it's quite simple, right? Because I could have just said item view holder here, and everything would have been fine. But then I couldn't use this with any other type of adapter, and I'd have to either copy this code and paste it again, or create a whole new class just for that adapter. But I can just type this adapter with type T. So you'll kind of see how that gets used in a minute. Now, if I just split this window over here, we're going to be looking at the main activity and the recycler view. So let's make this recycler view do as much work as possible, so that when somebody wants to use this, there's not really anything they have to do other than just set it up, with their list or something, and then everything just works. So one thing I like to do that's just kind of a nicety is just set up your layout manager in your recycler view, especially because this is a special type of recycler view where we want to have this thing be a horizontally scrolling scaling view. So we want this to be a horizontal linear layout manager explicitly, so we don't want them to set it up in the activity. We want to set that up ourselves. Now this wants a context, obviously, and this worked in an activity, but in a view context, we just want context, because this comes from, we are in a view class, an Android view class, and all Android views have context. Next up, we're going to be doing that data adapter data observer I was talking about earlier. So basically, we're going to take this adapter, the one they passed in, and we're going to add registered adapter data observer. Man, that's a mouthful. So we're going to create a new object, RecyclerView adapter data observer. And this isn't important. Just remember it. If you don't know Kotlin, it's okay. You can always just copy this code that I'm going to post later on GitHub, and you can just convert it to Java, and you'll be good. Just remember, syntax isn't as important as the actual what's going on. So I'm just going to Control I. There should be something I can override in here called unchanged. Yep. So whenever this data changes, whenever this adapter's data changes, we're going to want to do something. So first, once this adapter changes, if you just think about how recycler views work, right? First, you pass in your data to the adapter. And once you do that, the recycler view is going to try and populate its view holders and bind that, or create their view holders and then bind the view holders that it needs to. Now, all that takes time, so we want to make sure that once this data has been inserted into the adapter and notified dataset change in the recycler view, we're going to want to wait till everything has been finished drawing on screen. Okay, so we're going to do a post, and this just means, hey, wait until everything on this view is done. Wait until its layout has been calculated. Wait until onDraw has been called and finished. Wait for its children to set up. Just know that post is, we're waiting until this thing is absolutely done doing what it needs to do. And that's kind of important because we're going to be working with the child widths and stuff like that. So one of the things that we think about, let's go back to the emulator for a second. If we want this view to scale to the center of the screen, it would look kind of weird if this still started out. This is the first item in the list. It would be kind of weird if this didn't start in the center of the screen. So let's make this a little bit more nice real quick. So what we're going to do, come back to Studio. We're going to set up the side padding for this recycler view. So the side padding, if we want to center this view in the screen, let's come over to GIMP real quick. So we can, we'll come back to this later. So if we wanted this view to be in the center of the screen, so if we had a screen like this, and we had a view in the center with, it has, I'm just going to draw the view bounds, but, it has a view bound basically. So this is the view in the center of the screen. Now, we want, this is a great dotted line, but we want the center of the screen. So what we can do is we want if we consider this the width of the recycler view, we want the width of the recycler divided by 2. That'll get us this width here, this dimension here. But then we would also need to get the center of this view divided by 2. And that would give us the center of the view. You'll see how this works out in a second. But the point is that we would want the width of the recycler view divided by 2. which would give us the center of this recycler. And now if we just said the padding was equal to that, then this view would start off here. Of course, centered vertically, but it would start off here. But we want to offset it by half the width of this, or subtract half the width of this from the padding that we're trying to set, so that it is centered horizontally. So, I don't think I switched back to GIMP for that. I apologize, but let me just show you what I drew there. So this view here would be set on the left bound in the middle, but if we want it to be centered horizontally completely, we would need to subtract half the width of this view from the padding that we're setting here, and that will shift it this way to the center of the screen horizontally. So to do that, we set the side padding equal to the width of the RecyclerView divided by 2, and then minus, and all of our children are the same width, so we're just going to cheat a little bit, and we're going to say get child at 0 dot width divided by 2. And then we're going to say set padding, side padding, and then top is going to be 0. We don't want to change that at all. Right is going to be side padding, and bottom is going to be 0 as well. We don't want to change that. And then just to make sure that everything gets initialized properly and that everything really is centered in the screen to start off with, we're just going to say scroll to position 0 just to make sure everything is centered on initialization. And we'll start with that. So what we're going to do over here is in the activity, we are going to we set up our adapter by now doing item list initialize with item adapter. We pass in our adapter to our initialize method that we have over here. And then that really should be it. We shouldn't really need to do anything else to get this to work as is. So I'm deploying it to the emulator, and we're going to check that out now. One second. It looks like we're actually getting a crash. Good stuff. So let's check out the logcat. Let's check out error. So get child at 0 must not be null. So let's think about this. Interesting. Oh, I see what I did. It's not really apparent, but what I didn't do was, first of all, I passed in this adapter that I wanted to initialize this RecyclerView with, and I added this data change listener on it and everything, but I never set the adapter. So adapter is going to equal adapter. And let's just rename, so you could just put this dot adapter is equal to adapter, but let's just rename this guy real quick to new adapter. If I could spell correctly. Wow, new adapter. And then this is just going to be adapter. So we have new adapter being passed in. We're setting up a data listener on it, and then we're setting up the adapter. So we were trying to get this child at 0 when there was no child at 0 because the adapter was never set up properly. So let's go ahead and run this again. And switch back over to the emulator, and we should be good to go. So there must be some slight calculation issue because this really isn't quite centered. No, okay, right. So as you can see, these views are being cut off. And this is going to be because, so we set the padding. You can see this white space here is the actual padding that we set on it. But we need to set that line in the XML I was talking about earlier. So there's going to be, all views have a clip to padding attribute, and you're going to want to set this to false. So basically we're going to say like this RecyclerView should have this padding in it, but its child views shouldn't be cut off by that padding. So let's try and I just didn't switch back to my studio again, I'm sorry. So in our RecyclerView XML code, in the activity, we're just going to say clip to padding false on the RecyclerView. If we come back over to the emulator, I'll deploy this again, and there we go. So now we have, it's still not quite centered, but for the sake of this video, I'm not going to gold plate this too much. But basically, we can now start off, let's just assume in the center of the screen, and scroll, 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 and then the last item in the list should do the same thing as the first item. And it's not, you can center it in the screen. So I think that's good enough for now. Let's not spend too much time on that portion of it, because that's not really the point of this, but it's just kind of a nicety to have. So what we're going to need to do, if you think about it from a high-level perspective, we want these things to change scale when they're scrolled horizontally. Now, how are we going to get the position every time we scroll? So one thing we can do is add on scroll listener. Where is it? Here we go. Is a method on a RecyclerView, and this is going to be triggered every time that the RecyclerView is scrolled even 1 pixel in any direction. So this is going to want an object of type RecyclerView onScrollListener, object of type onScrollListener, onScrollChangeListener, or is it onScroll? I think it's just onScrollListener. Let's go with that until it bites us in the butt. And we're going to want to construct that. And then we're going to want to override onScrolled. Okay? So every time this is scrolled, this block of code is going to get called. Let's make, this is starting to get beefy in the initialize function, so let's bring out a new method called onScrollChanged. And this is going to be everything that happens, and we'll call it here onScrollChanged. And this is going to be, so this method is going to be called every time the RecyclerView is scrolled even 1 pixel. Now we're going to want to, if we come back to the emulator here, if this is in the center, if this is in the center of the screen, this is going to be the largest scale possible, and this view holder over here is going to be the smallest scaled possible. And as we scroll these things, new views come into screen and stuff like that. But the point is that we're going to have to redraw the scale for all the views whenever their position changes. So whenever the scroll changes, we're going to want to go through and just make sure that, we're going to post once again, just to make sure everything is done, being, data being set, views, children being set up properly, because we're going to be using the child's widths and X positions, Y positions, stuff like that. We want to make sure they're 100% finished laying out before we try and alter their scale or anything like that. So once everything is done being set up on the screen, we're going to do a loop from 0 until child count. Now child count is a RecyclerView property, of course, that just says how many children it has. And then we're going to do a for each on that. And once again, this is just a for loop from 0 to, if there's 40 children, from 0 to 39. So yeah, pretty simple. So we're going to say val child is equal to get child at. Hold on a second here. Get child, oh, there it goes. Okay, I had a mistype. So get child at it. And just to not scare away any Java developers, we're going to say index, or we can even call it position or whatever. Position. And you Java developers should be familiar with Java 8 lambdas anyways, so this shouldn't be too scary for you guys. So child is equal to get child at position. And then if you guys remember how we set up our Gaussian function earlier, we're going to need the x center of the child for our Gaussian function. So if we can think about it, to get so if you did child.x, right, that would give you at some anchor point on that view the x position where that screen is where that view is on the screen. So let's bring back our algebra skills here, maybe some geometry, and just say child left plus child right, and we're going to divide that by 2, and we'll say we'll call that child center x. So what this says is if the child is in the center of the screen, we'll just assume, the phone is x pixels wide, or, some amount of pixels wide, but this would be something like 400, and child right would be something like 440. So, 400 plus 440 for 840 divided by 2, you would get 420. Childish jokes aside, that would be the center of the view on the screen. So that would be our driving force behind getting the center of the child x. So that's one of the variables taken care of for our Gaussian function. So next thing we're going to want to do is get some kind of scale value, right? And this is going to be Gaussian function. And this is going to be a little bit complicated, like I mentioned before, because we're going to be converting this, kind of higher order calculus, or not calculus, but, algebra, calculus, whatever function into some kind of flat Java function. And it's not going to look so nice, but we're going to hide it away in another method. Call it get Gaussian scale. And we're going to want to take in the child center x, which is going to be an integer. And then we'll just start there. Let's see. It might be better just to set everything up now. So I'm just going to choose some arbitrary names to set for those other Gaussian function variables, and we'll come back and update those if we need to, and I'll explain everything as I go. But these are all just derived from the function that we created earlier in GIMP, and yeah, we'll get this all set up. So we want to get the recycler center x. It's going to equal, we're going to use the same logic as we did to get the child center, and just say left plus right divided by 2. Now we got our recycler center x, and if I come back into GIMP, do I still have this pasted from earlier? I don't. Maybe I can get it back. Oh, there it is. I went too far. Cool. So basically, we have x, we have b, we don't have a yet, but that's what I named. I'm sorry, I'm on the wrong screen there. So we have a, or sorry, we have x, we have b. We don't have a and we don't have c, but I named a. And I named C for us in Studio. So if we come back, I named minimum scale offset for A. Or sorry, scale factor is A. Spread factor is C. And minimum scale offset is going to be some kind of factor that we can really just change the spread if we wanted to, or the scale if we wanted to. Just something a little bit more customizable. So let's just get into the worst part about this entire setup, and let's just create this Gaussian function. So to do powers in Java, it's a little bit gross, but math pow, and then so we want to say math.e to get our e constant. We can do let's see. Yeah, so it's going to be e to the power of, and then we're going to need to do another math.pow, child center x minus recycler center x. So that was our x minus b, and this wants a double, so we're going to do a 2 double on this. What am I still missing? I think that's everything for that. Oh no, I am missing. Right, so then I need comma 2. So basically I'm saying negative math pow, so negative of x minus b and then squared. And then after that, I think this still wants a 2 double. I think it wants the 2 to be a double as well. So I'm going to close out of main activity, because I think we're done in there, and I'm going to close out of our adapter, give us some more room over here. This is going to be a long function, so we need all the room we can get. Right, so let's just make sure we got everything right. So math E is a double, I believe. Yeah, math E is a double, and math pow returns a double. So math pow wants a double double, so we've got a double double, and this math pow wants a double double, and we've got a double double here. So after this guy, we're going to want to do divided by to get the bottom part of our fraction, the exponent, and then we've got another exponential coming up here. So we got 2 times, this is going to be c squared. So math pow of spread factor, which is c, and then we're going to multiply or put it to the exponential of 2 double, because it wants a double double. And we're really getting in the weeds here. We got a lot of parentheses and whatnot, but I think here we would want to, or not a comma, we would want to multiply by the scale factor, which is a, or alpha. And then this minimum scale offset is really because the Gaussian function would normally return you a value from 0 to your scale factor. And we wanted this to return a float, to float. Looks like I got something to fix up in a second. But, wait, yeah, I didn't give this a return type. We would want to return a float, and this would want to be to float. I still got something wrong here. Oh, this comma shouldn't be here. And this would want to be a to float. Okay. Wow, that was a lot of work. But basically, this minimum scale offset is because the Gaussian function would normally return a value from 0 to your scale factor, and we don't want a 0 scale factor, because if we look at our emulator, if we had something at a 0 scale factor, that means this icon here would be completely invisible at the very edge of the screen because it would have a 0 scale factor, and we don't want that. We want this like normal, as this view is right now. We would want this to be like the minimum scale when it's at the edge of the screen. So we're going to give a minimum scale offset of probably like 1 or something, but we'll figure out all the numbers in a second. It's going to take some trial and error to get it right. So we come back into Studio. We now have our Gaussian scale function set up. So to get the scale factor, all we need to do is call get Gaussian scale, and this wants child center x, which we already have set up. The minimum scale offset, we'll give it a shot of 1f, I think, because that should keep it the same size at the edge of the screen. The scale factor is basically going to be how much do we want this to be greater than the minimum scale by. So I'm just going to say 1f. So what this means is if this is the offset and this is the scale, it's going to basically be a range from 1 to 2 from the edge of the screen to the center of the screen. The spread factor, we're going to need to do a little bit of trial and error with this, but the lower this number is, the lower this number is, the tighter that bell curve is going to be. The larger this number is, the wider this bell curve is going to be. So let's just start with a number like 10 or something, and this wants a double. So we're going to say 10 to double. We'll figure this number out in a minute. But now that we've got the scale value, we just have one thing left to do, and that's going to be set the actual scale value on the child itself. So we got scale x is equal to scale value, scale value, and scale y is equal to scale value. That's a lot of work, but let's see if it even works. Let's put it on the device and head over to the emulator. Oh, there it is. Check it out. It's actually working. It's hard to tell, but it is actually working. We just have a really tight bell curve right now. So if you could think about this like a bell curve, the center of the screen is where the bell curve shoots up like there, but as soon as you start to get away from the center of the screen, it very quickly unscales. And that's because our bell curve is too tight. So if we come back into Studio, this number here, we're just going to want to raise this up. So if we set this to like 500, I don't know. I don't know what I should set it to. Like I said, it's all trial and error, but like 500 or something. Here we go. Now we're getting something. So this bell curve is way too wide because all these views are being scaled. Oh, I'm not on my emulator. These views are way too scaled on the edges of the screen. There is really no difference between the center and the edge view holders at this point. I mean, it's very slight. So let's come back into Studio and just keep adjusting this. We had 10, now we're at 500. Let's just try something like 150 or something. I don't know. Go back into our emulator. Yeah, now we're getting there. Oh, it looks pretty decent. The text views, text is getting clipped off. Let's see. It's probably going to be something to do with the padding on the views itself. So let's go into, back into Studio. Let's go into our list item. And we have a bunch of padding values on here, but the padding top and bottom, we could probably raise this to, I don't know, something like 40, 64, I don't know. Just give it enough room so that when it scales up really largely, that everything still looks good and doesn't get cut off. And it looks like I changed the wrong value. I wasn't paying attention. What did I change? I changed top and end. That's not what I wanted to do. I changed top and end, so let's change top to 64. Let's change bottom to 64. All right, let's go back to our emulator. Here we go. Now our text views are not being cut off. And it's looking pretty decent. Yeah, looks pretty good. There's a couple other things we can do with this, though, to really make it look nicer. So one of the things is we want to like really put a more of an emphasis on the center view. So one thing that we could do is put more of a gray tone on this view back here. You know, as it goes from the center of the screen to the edge of the screen, it would go from blue to gray. I think that would look pretty nice. So that's going to take some extra work. Let's come back into Studio and just trying to figure out how we want to do that. So we got our on-scroll change. We set up our scale. Let's set up a new function called RecyclerViews, and we're going to call this after we're done scaling it. RecyclerViews. This is where things are also going to get a little bit hairy. So we need to know what color. First of all, what colors. So let's define a couple colors up here. Private val by lazy. Or sorry, we need to give this a name. Let's call it like active color or something like that. And let's do a by lazy. And we'll say context compat. Wherever he is, context compat, get color for context, and r.color.blue. So this is going to be our default active color, and then I guess we'll just call this one inactive color, and this guy is going to be r.color. I've already got gray defined. So I've got blue and gray defined in my XML colors file, and those are going to be our active and inactive colors. We're also going to want to pass in some views that we're going to want to change the color of. So let's have a list of, I don't know, views to change color or something. I don't know. The name's not too important. This is going to be a list of ints. Could just have a list of views, but I think having the ID of the view would be better at this time at least. So I'm creating a empty list of integers basically at this point. That's all going to change here in a second. So that means we would want a way to set up what views this thing is actually going to be changing, because this recycler view doesn't know about any views. The activity, or whoever's using this recycler is going to have to. They're going to be the ones owning the views. They're going to be the ones knowing what views are going to be changed color and stuff like that. So set views to change color or something like that. So we'd want to take in a list of view IDs. That's going to be a list of ints, and we'll say views to change color equals view IDs. Okay, so I lied about being done in the activity earlier, but we're going to say, after we initialize the item adapter, we're going to say item list dot set views to change color. And if we think about it, we really want to change the color of a couple things, because we have this blue text view under the circle. Let me switch the emulator. We have this blue text view, and then we also have the blue circular background. And we're going to really want to change the color of both of those things. So let's set up a list of here. So we're constructing a list of IDs. And if we open up our list item file here, we've got list item background. The icon will just stay white, so that's fine. We don't have to update that. The list item background and the list item text are what we're going to want to change. So in the activity, we're going to want to pass in a list of r.id.listItemBackground, oops, and r.id.listItemText. So we're setting the views to be changed color of for list item background and list item text. Now we should be done in the activity, and the adapter should now know about what views that it's going to update every time the scale changes. We've got our color set up. The last thing that we have to do, and it's going to take a little bit of work, excuse me, but we're going to want to change the color of the views itself. So inside of color views, we're going to need to do a little work. So if we think about this, let's pass in the scale factor. Scale factor, which is a float, I think. Yeah, I think it's a float. And we'll say, we're going to change this to color view. We're going to pass in a child, which is a view, and then take in a scale factor, which is a float. Oh, float. And then this is going to be color view of child. Yeah, okay, that looks better. So we're going to take child and scale value, and now we should be ready to try and color up these things. So if we think about it, the scale value is going to be from 1 to 2. So how do we translate that into how much of a color change we want? So in my head, I think we're going to be using a color matrix. That way we can like set a saturation on that matrix and apply it to the image view. And that saturation, or we're going to have to set a saturation on the matrix with some kind of percent value. And that percent value is going to be from 0 to 1. But that's kind of out of the range from 1 to 2, right? So if we think about it, our saturation percent is actually going to be from, we want it to be from 0 to 1, but right now it's from 1 to 2 because if we remember from earlier, the minimum we want our Gaussian to return is 1, and the maximum we want it to return is 1 plus 1, which is 2. So we're going to do a little bit of hard coding here. We probably want to pull these out into constants or something like that, but for now this is okay. So we want to take our scale value, or scale factor, sorry, and I'm going to rename this to scale value. I keep saying scale value, so I'm just going to rename it. So we're going to minus off 1 from this, and then we're going to divide it by 1. Now this says right here that since the scale value can be between 1 and 2, if we subtract 1, it can be between 0 and 1. And then if we divide it by 1, we should get a number between 0 and 1 percent-wise. So we're going to define a new matrix. We're going to call it color matrix. And then we're going to say apply. We'll try and keep as much Kotlin out of this as possible. So matrix.setSaturation. Is there? Yes, set saturation with saturation percent. And right now we're only going to worry about the image view. But views to change color. This is our list that we instantiated earlier. We're going to go through every one of these things. Let's see. Let's think about this. So we have the child here, which is the view holder. And we want to change each of these things on the view holder. So first we're going to need to look up that view to change color by ID. So view to change color is going to equal child. So we want to operate on the child specifically. Find view by ID for whatever kind of view. It doesn't really matter at this point. Let's call this view ID and view ID. Okay, so we've got the view that we want to change the color to, and let's just make sure that we're operating on an image view, and if we're not, we're just not going to do anything with it for now. We'll just worry about the image view. So if it is an image view, then we're going to do some stuff to it. So view to change color dot color filter is equal to color matrix color filter for matrix, and then let's see, view to change color dot image alpha is going to be equal to I think image alpha. So the set saturation on a matrix takes a percent value from 0 to 1, but the image alpha is going to take a value from 1 to 255. Is that right? Yeah, 1 to 255 or 0 to 255. So we're actually going to need to set up a second percent value here. So we'll call this alpha percent. And this is going to be, so if it's from 1 to 2, we can just make this from like scale value divided by 2f. So this 1 to 2 is fine in this case because the alpha percent on the icon itself, the white icon, it's okay if it's not completely 0. We don't want it to be completely invisible, but we want it to be alphaed out so it's not in focus as much. So this is going to basically say that the alpha percent is going to be anywhere between 0 or between 0.5 and 1. That's good. So, but we want this to be in the range of 1 to 255. So we're going to do 255 times by alpha percent. And then I think this one's an integer. Yeah. Okay. So basically what this boils down to is it's going to be between 122 and 255 for the icon image. Yeah, I think that's a good start. Let's fire this up and see what it does on the emulator. Yeah, that's looking pretty nice. So as you can see, when you move something towards the center of the screen, it starts changing to blue very slowly. And then once it's finally in the center of the screen, it's full blue. And then once it's on the side of the screen, it's full gray. Yeah, so this is looking pretty cool. But the last thing we have to do, like I said, is update that text view color. And let's get that done now. So if we come back into Studio, if you remember earlier, we just had a check for if it's an image view. Let's have a check if it's a text view, because all these custom views or all these views that you're implementing in your view holder, you change colors of them in different ways. Like for image views, you can do color filters or image alphas or stuff like that. But for a text view, you just set the text color. So like different Android views require different ways of changing the color. So that's why we have to break this out into separate methods for each type of view. So let's just say let's make a color, and this is where it gets kind of hard. I've worked with these before, so I'm more familiar with them. But if you guys have never worked with an ARGB evaluator, what this does is it allows you to, because we want this to have the same effect as the blue to gray or gray to blue change towards the edge of the screen or towards the center of the screen. So you have to be able to get a value between gray and blue that is the right amount of way between both colors at certain points on the screen. It's hard to kind of put into words, but basically we want to create this evaluator, and then we're going to evaluate the saturation percent. So from 0 to 1 of inactive color. If it's 0, it's going to be more of the inactive color. If it's 1, it's going to be more of the active color. And then view to change color dot set text color for color. We'll call this text color. This one's an int, so we're just going to cast this as an int. I don't know if I like as int or to int better, but oh, it looks like it has to be as int. Okay, so yeah, let's give that a shot. Let's go back to our emulator. Yeah, so now you can see on the edge of the screen the text color is actually gray instead of blue, and as you fade it in, it slowly becomes blue, just like the color of the background. Yeah. So this can be used in a lot of different ways. You can have, you can use any amount of custom views you want in this view holder. You would just have to make sure that when you're setting up the color of your views, because the scale of the view shouldn't matter. This should all work no matter what you have in your view holder. But when you want to color your different views, for every type of view that you're passing in your activity, so I think I have main activity here. So I'm passing in this image view and this text view. But if you pass in any more, like I don't know, an edit text or something, whatever you have, you would need to set up another check for it in this view to change color. But yeah, I think that's going to do it. I've kind of gone a little bit more depth than I really wanted to in this video, and that's okay. Like I said, I'm going to be posting the GitHub source code link in the description below. I'm going to be posting the blog post link in the description below. So if you guys want a quick recap, it'll be in the blog post. If you just want the source code so you can copy and paste it, you're more than welcome to use that, and it'll be in the GitHub. So thanks for your time today, guys, and see you next time. And also make sure to let me know in the comments below what you guys want to see next. I've done a lot of custom view code, and I'd be happy to not only show you guys what I've done in the past, but if you guys have requests, I can definitely try and recreate anything that you guys see in other apps. And yeah, I can definitely try and do that. Thanks, guys. Appreciate it.